In this section, we'll return to Swift custom types and cover some more features that are essential to mastery of Swift. We'll start by looking at Swift access control and understanding Swift organizational units. We'll then look at the final keyword and finish up with some smaller features to work powerfully with custom types, custom getters and setters, custom subscripts, nested types, and type aliases. First off, access control. If you've worked with almost any modern language, you'll be aware of the concept of access control. This is where we intentionally limit the visibility of parts of our code in order to maintain control over how it's used. Of course, Swift has access control features. Let's take a look. But before we start to detail the access control system of Swift, we need to understand the organizational units that access control is built around. Once we understand this, we can see how access control levels work within them. Swift has basically only two units of organization. The first and smallest unit of organization is a Swift source file. This is a discrete Swift source code file on the computer file system. The next organizational unit is a module. What's a module? Well, you can link your understanding of modules with our discussion of bundles. They're quite similar. A module is an application package. This means the first module we've worked with is in a playground. When we think about access control, a playground is a module. However, a playground is not a good example of a module for understanding access control, since we can't share a playground as a unit of code that other people can include in their projects. They can only run the playground and edit code within it. What is a good example of shared code that we've already worked with? Of course, it's Foundation. It is a package of shared code. Some of this code is available to its users, but much of its code is designed to be hidden away within the module. This means that generally speaking, framework and module mean the same thing. In fact, framework is a term that predates Swift. There are some small differences, but for the time being, consider them to be the same thing. Now that we've introduced Swift's organizational units, let's look at how its access control keywords interact with those units. Don't worry if this seems a little complicated. It's important to introduce all the levels now, although you can start using them more gradually. We'll start with the simplest and most restrictive level, private. Private is very similar to the private access control in many other languages. It restricts access to a type and any extensions of that type within the same source file. This last point is quite important. File level access control is more significant than type level control in Swift. We'll illustrate this in practice later. The next level is file private. This is probably the most confusing access level in Swift, and its meaning has changed in Swift 4 in order to make it less confusing and actually less important. File private is somewhat similar to the protected level in other languages. It makes features visible to subclasses, but only if they're defined in the same source file. Don't worry if this seems confusing, we'll illustrate the difference later. The next level is easier to understand. Internal gives access to any code within the same module. This means within a framework like Foundation, any shared helper code can be marked as internal and can be used by any type or function within the module. Notice that I'm enclosed internal in brackets. This is because internal is the default access level. All the code you've written so far has had the internal access level. This means it's not necessary to write this keyword in your code, although sometimes it might be useful to do so. After internal, we cross the module border. The next two levels control access to code that imports a module, such as Foundation. The next level should be familiar. Public. Public makes code accessible outside of the module. This is how you would define the public interface of a type in a module or a framework. There is, however, one more access level. Open. What's the difference between open and public? Public code is not subclassable. Open class code is subclassable. Public class code is not subclassable. You may remember that we talked about Swift discouraging the use of inheritance. This is a strong example. Making your class subclassable is an additional access level. This means if you're designing a module, you should think about whether or not your type should be subclassed. Also, this means when you're looking at a module such as Foundation, you can easily see which types are designed to be subclassed and which are not. A public class is publicly available, but it's closed. It can be used, but it cannot be modified. It is not subclassable or overridable. Open class code, on the other hand, is subclassable and overridable. An open class can be subclassed by a class outside its module. Also, its properties can be overridden. Let's show a quick example to make that clearer. Here we have a class called module class that's inside a module called myModule. The class is open. This means that if we import the module, we can subclass module class. We can also override its properties to change its behavior. Here I've overridden the property called property and I'm returning a different string.